Today we're going to be doing a real power outage generator test at this high school. This school has this 600 volt, I believe it's a 60 kW emergency generator. We'll check the nameplate on that, and we're going to be simulating a real power outage and seeing exactly how long it takes and just what happens. I've done this video a couple times before, but people seem to really enjoy this one, so I'm doing it again. This generator is something we are supposed to test monthly, make sure it runs up when starts, and annually it has to get tested for 2 hours with the load bank with a heavy load on it. This high school needs this emergency generator to power a bunch of different critical loads. Those are the fire alarm system, the huge atrium smoke control system that turns on big fans to suck smoke out, and pressurization fans in stairwells, as well as the fire alarm system itself. And very importantly, this powers all of the emergency lighting. So in your hallways and large occupancy areas, anything with the occupancy over 60, as well as all the lighting in stairwells and bathrooms, those all have to be on emergency power. Therefore, in a power outage, they will keep running. So about half your corridor lighting is, and then certain lighting in the gym and shops and libraries and other high occupancy areas, and then all of the lighting in the stairwells. Actually, this room here too, these lights are on generator power. Which means when we have this simulated power outage, these lights will go off, as well as in the electrical room where I will be standing as well. So you will see those lights drop out, and those will give you a time period for how long all of the emergency lighting in the school is going out for. All of the non-emergency lighting, everything that would be off in a power outage, won't go off in this test because we're not going to turn off the main breaker. We are going to be turning off two smaller breakers that feed both of our transfer switches. We have a life safety transfer switch and a general backup power transfer switch. Our life safety one powers, well, everything life safety. So your fire alarm, your smoke control, which is part of the fire alarm, and your emergency lighting, and I'm sure some other stuff I can't think of at the moment, but your general backup power powers things like your data racks to keep all of your data and communication going. Because this school has a generator, we do not have battery backup emergency lighting like you would see in many buildings, except for 2 units. There's one in the generator room and one in the electrical room. Those are required to be in the electrical room and generator room in case something's to go wrong with the generator, to provide light for manual operation of the unit. This generator here runs on diesel. This has to run on diesel because this school and many of our other schools with generators are designed to be a community shelter. They are built to the higher earthquake codes and standards, more like a hospital, fire hall, those type of structures would be, because they need to be, unlike many other buildings where they may survive the earthquake, but they can't legally be occupied after that event. This building, because it's an emergency shelter, has to be still occupiable after such event. Therefore, the generator needs to run on diesel because natural gas lines will shut down in any seismic activity. So that's why this is a diesel generator with the tank underneath it. I believe this would get around 30 hours of use if I was to calculate the time it gets from one tank, but that obviously can be refilled during the outage as well. This is powered by a 4-cylinder turbocharged diesel. This is a John Deere engine on this, and this has an MTU generator head and controller on it. It's an MTU generator. You can see it is in auto, as it should be. Fuel is right full. You can see that the block heater's working, keeping the temperature up, and battery voltage is fine. So there you go. You can see it's designed to run at 1800 RPM to hold 60 Hertz, and that is 60 kW or 75,000 volt amp. And that gives you 72 amps at 347/600. Ignore that it says 346. That should say 347/600. This is a 3-phase generator, of course. 72 amps, of course, is a quite small portion of this building's total 1200 amp service at 600 volt, but that's because this is only doing emergency load. It's not running any heat, any cooling. It's not doing the elevator in this building like they do in many. It's just doing emergency lighting, and that smoke control system is a huge load. Brief sequence of events here. We're powered off of utility, closed in on utility, going to the load. Our frequency pickup, 54 Hertz, 90%. We have a 3-second start delay, so power has to be out 3 seconds before we start. Our warm-up time is 4 seconds, so that's how much time the generator runs before transferring load. cooldown time is 2 minutes. That means after power is restored, generator won't go off for 2 minutes. And our neutral delay 3 seconds means while switching between power sources, it will wait 3 seconds. That is good for, you need that for motors and some sensitive electronics. You don't want to be switching frequencies all of a sudden. Here on the other side of the generator, we have the engine's nameplate there. So half of these corridor lightings, about that, is on generator. You will have night lights in the gyms that will be on generator, and all stairwell lighting is on generator. And then any other room with a occupancy over 60 will have some emergency lighting. That means classrooms don't need emergency lighting, but also bathrooms do have it. And this big atrium here also does have quite a bit of emergency lighting. So these are the two breakers we'll need to turn off. We have our generator transfer switch and our other generator transfer switch. Our 70 is the life safety. The 40 is the backup, general backup power. On this one line diagram here, you can see exactly where that 70 comes off the 1200 amp main distribution, 70 and the 40, double bypass automatic transfer switch. That is our generator, 60 kW at 600 volt, and you can see what that's feeding. So this is our life safety. It's supplying all those fire exhaust fans, and then we are also 600 volt on that side going into a transformer. It's taking us down to 12208, and that is our emergency power at 12208, which is doing all of the emergency lighting and pretty much everything other than those supply fans. And then on our standby side, we are going again through a transformer, taking us down to 12208, another 30 kVA, and then we are going into a 10 kVA UPS, which gives us 40 amps out, and that's doing the data panel. So that panel provides everything data. So that UPS is right here. That's doing the data room over there. If the panel has a red Lamacoid label, that means it's emergency power. You can see this one here is one of the emergency panels. And for some reason the fire alarm is on the backup power, but not the main power, not the emergency power. Why that is, I don't know. But you have UPS, fire alarm panel, heat trace, and that's about it for that panel. As the other panel, the data panel, is actually on the UPS as well, so that panel will never ever go down. This transformer is providing that. That's one of the 30 kVAs. Here's the other 30 kVA, which is fed from this 347 600 volt. You can also see that mineral insulated. That is doing one of the supply fans. It needs to be that to withstand fire, as it's going through multiple fire zones and it needs to have survivability for a long time. You can see this panel here is doing some of our smoke fans and our 30 kVA transformer, which then comes out of this transformer, does this 12208 panel. This does a lot of our lighting, and that goes into this lighting control panel. Because most of the major lighting in this school is on lighting control, it needs to have the generator power going through this lighting control panel, because all these modules will turn on the emergency lights. So should the power go out and the lights are off, those will automatically turn them on and override any human input into the system, basically forcing every light to come on. That is a designated emergency light. All right, that's enough talk. Let's turn these breakers off. I'll start with the emergency one, as that does the lighting, so I can get a realistic timing on how long this system will take to start, and then I will hit the non-emergency power. Let's get it. And we are now running on generator power. and our systems have all restored now that the non-emergency power took a little bit longer to come back on, as we did that transfer switch second, and we can go see the generator running. Here you can see one of those smoke control fans. This is a pressurization fan for this stairwell, because this stairwell doesn't have fire doors at every level. So this stairwell is pressurized to remove any smoke from it. I have a whole video on the smoke control system in this school. A few videos actually, one just showing it and one doing a walk around of how it operates. Pretty interesting stuff actually. Okay, so it's gonna get a little bit hard to hear me. It is pretty noisy. Obviously, the generator is running. You can clearly hear that. And looking at the transfer switches, you are able to see that utility power is lost. Therefore, we are no longer closed in on that source. Generator power is on, and we are closed in on that power source going to our load. You can see 60.1 hertz. So we're putting out power and we're running on it. This is our backup power. This is our life safety transfer switch. If we look right here, we're pulling 22 amps. Remember, we can pull up to 72, so we're not loaded too high. That's because we're only running all the emergency lighting. The biggest load here that's on generator is the smoke control system. That's a huge, massive motor load. Temperature has gone up slightly, not super high yet. 68 pounds around 60.1 hertz. Battery 14 volts, and we're running on the alternator. This damper to the outside has opened up. This is where air is coming over the radiator. I believe it's pulling the air in through there, over the radiator, out the building here. And this will open up or close depending on room temperature, I think. Not exactly sure on what this damper is doing here. But we can go look at this from the outside and see where the diesel exhaust goes to the outside of the room. It's really noisy in here anyway, so I want to limit my exposure to the high level in here. Can't really see the exhaust much, but it is there. That's that gross brown exhaust pipe, all rusty from the heat. Paint won't really stick to that, I wouldn't think, but that's the exhaust. And this is our air being thrown out from over the radiator. You can see two stairwells. There's one there, one there. This school has in total 6 stairwells. All of those have 24/7 lighting. It's good for the generator to run for a little bit, get nice and warm. Of course, we're not running it at high amperage, which I'm not a diesel mechanic, so I can't speak with any knowledge behind this, but people have told me that that's when you'll get wet stacking, which I believe that is true, is when you're running at lesser load. I've also been told modern diesels don't suffer from that as badly. I don't think we've got any going on here, as the exhaust looks pretty clear. However, this is now April anyways, so we're getting into spring, and every summer these get ran at 100% load for 2 hours, so that'll burn any of that off. So that's good for them to run hard like that. Feel warm air over the radiator, and then very hot air up there. Ask my friend about that one. He can tell you all about how hot that is. Now these bathroom lights are also all generator power. So the last few times we've done this test here, the fire alarm hasn't got the generator supervisory, which it should be for whatever. Okay, so now it is getting it, but it should be actually audible. So something's been changed here. So it is recognizing that the generator is running.
Maybe the trouble's audible, not run.
No, it should be put into an audible supervisory. That's what it usually does. I guess maybe that's fine as long as it realizes it's running it. So I think that could be it, that's set to an equipment monitor, so it's not audible like what the doors are. Because these doors here are monitored for their position by the fire alarm if they're open or not. It's just not, doesn't actually show up on there. I'm going to turn the power back on now, and then we'll enter a time delay of waiting till we switch back over. That's when you'll be able to see that neutral delay, and then the generator engine will run for a couple minutes before shutting fully down. So we'll turn those breakers back on. Again, I'll start with the life safety one so you can get a realistic demonstration of how long that will take. So now we have entered the time before switching back to utility power. Basically, this is a power outage. Power has just came back on, but we're still running on generator power for a little bit. So we have to wait until the generator has its utility delay over. Basically waiting, making sure that utility power is stable. There's no sense of turning off the generator back onto utility power if that power is not a stable source. Our load on our main service is super low today. A phase 153 amps, B phase 164 amps, C phase 128 amps. Remember too, 20 amps or 25-ish amps of that are on the generator. Like there would be 25 more amps on our main service if we weren't on generator power. Oh yeah. Yeah, they're on. Well, that's actual trouble because the fire alarm lost power. I'm now going to see the generator running without any load. No, it's okay. And we'll be able to see that there's 0 amps on the generator. So it's really important for a turbocharged diesel especially to run without load, because you don't want to shut down a red hot turbo, because that's how you seize parts in place and they won't ever turn again. So you don't want that. We are powered off of utility power. However, generator voltage is there, so the generator is still running. 0 amps. can see, generator is no longer being shown. That damper shut. This guy seems to always be a little sticky over here. It's closing normal today. I can demonstrate a lamp test on all of this too. A lamp test just tests all of the display and all the different lights are good. Lamp test on here is if we hold these two, you can see all the lights light up, the display, all the pixels are good. Turning around here, we have this remote display. This is where there's also a piezo on here. This thing screams if there's any problems. So it'll show what issues there are with the generator. If low coolant temperature, high coolant temperature, low oil pressure, over crank, meaning that it's been cranking the engine over but the generator didn't start. Over speed, if the engine exceeds 1800 RPM by too much or 60 Hertz. Emergency stop activated. That would be if I hit this emergency stop button to shut the generator down. That would be active. And we have high coolant temperature, low coolant temperature, low oil pressure, low fuel level, a weak battery, battery over voltage, battery charge failure, and then sender failure. Honestly, don't know what that is. Fuel leak sender failure. Yeah, not exactly sure what this is. I'm guessing this would have been up if this would have been lit up earlier when we were running, but I didn't see. Switch not in auto. If I was to take the generator out of auto and put it in run or off, that would not be on. So I will show the lamp test on here. You can see that is working. And on here, lamp test is if you hit both these, lights up everything, all good. Same with this transfer switch here. Lights up everything, all good. So yeah, guys, that's going to be it for this one. If you guys did enjoy this video, make sure to give it a thumbs up. And if you do have any comments or questions, feel free to leave those down in the comment section down below. If you do enjoy my channel, make sure to subscribe. Also, if you are interested, I do have an Instagram account at Pickle700 for bonus content, stuff posted earlier than you'd see it on the YouTube channel, that sort of thing. Alrighty guys, thanks for watching.